Today we shall discuss two important problems and very interesting problems on relation and functions, and more problems are given in my video recording and you will see from there. So today we shall start two problems on relations and functions. More interesting problem, very interesting problem I am discussing. The example is that let R1 and R2 be two relations defined on R by A R1B implies AB greater or equal to 0 and A R2B implies A greater or equal to B. Then first option is R1 is an equivalence relation but not R2. R2 is an equivalence relation but not R1. Third one is both R1 and R2 are equivalence relations. Fourth is neither R1 nor R2 are equivalence relation. Which one is true? So let us first discuss the first one. A R1B implies AB greater or equal to 0. The relation is this: AB greater than or equal to 0. Now to show the equivalence relation is true or not, we have to show the three relations. Number one, if a relation satisfies reflexivity property, if it is reflexive, number one, it is reflexive. Number two, it should be symmetric. And number three, it should be transitive. If these three are satisfied, then we say that the relation is an equivalence relation. So first one, whether the reflexive relation is satisfied or not. Suppose ARA holds. Then A squared greater or equal to 0, which is true. Which is true. So the relation is reflexive. R1 is reflexive. Next, we have to show that whether it is symmetric or not. Suppose A R1B holds. This implies AB greater or equal to 0. This implies BA greater or equal to 0. Therefore, R1 is symmetric. Next, to show the transitivity, whether it holds or not, suppose A R1B and B R1C hold. So this implies AB greater or equal to 0, BC greater or equal to 0. Therefore, you can say AC into B square greater or equal to 0. But from this relation, if B is not equal to 0, then we can say that AC greater or equal to 0. But if B is equal to 0, AC may be negative. So R1 is not transitive. This condition does not hold transitivity. Therefore, R1 is not an equivalence relation. We can say that, therefore, R1 is not an equivalence relation. Next, what about R2? The condition is that A R2B holds if A greater or equal to B. So for R2, A greater or equal to B, since equality holds, so this holds. Suppose A R2B holds. This implies A greater or equal to B. This implies B less or equal to A. Therefore, R2 is not symmetric. So this is not an equivalence relation. So R2 is not an equivalence relation. So R1 is not an equivalence relation. R2 is not an equivalence relation. So which one is correct? Number D. Here you can write R2 is not an equivalence relation. Therefore, option D is correct. Therefore, option D, neither R1 nor R2 is an equivalence relation. So, option D is correct. If any one of the conditions does not hold, then it is not an, three conditions does not hold, then it is not an equivalence relation. So let us come to the next problem on the chapter on function. Let f be function from natural numbers to real numbers and to n be function such that f of x plus y equal to 2fx into fy for natural numbers x and y, and if it is given that f1 equals to 2, then the value of sigma k equals to 1 to 10, f of alpha plus k is equal to 512 by 3, 2 to the power 20 minus 1 holds, is the four options are given 2, 3, 4 and 6. So we have to find out the value of k. what will be the value of alpha? Sorry, what is the value of alpha? Now, first we see that you are given f of x plus y equal to 2 into fx fy, and you are given f1 is equal to 2. First you find f2. What is our f2? f2 is equal to f of 2 equals to f of 1 plus 1. Apply this. F of x plus y is equal to 2 into fx into fy. It is 2 into f of 1 into f of 1. So this is equal to 2 into, you are given f1 is equal to 2, 2 into 2 into 2. So this is equal to 2 to the power 3. So what about f2? This is our 2 to the power 3. What is our f3? f3 is equal to f of 2 plus 1. This is our 2 into f2 into f1, and this is equal to 2 into, what is our f2? What is the value of f2? This is our 2 to the power 3. f1 is our 2. So this is our 2 to the power 5. So the value of f2 is equal to 2 to the power 3. f3 is equal to 2 to the power 5. So in general we can write fx is equal to 2 to the power twice x minus 1. This is our fx. Now what is given? F of alpha plus k is equal to f of alpha plus k. You are given, this is equal to 512 by 3 into 2 to the power 20 minus 1. Apply the given relation. This implies 2 into f alpha into fk sigma k equals to 1 to 10 f alpha into fk (512 by 3 into 2 to the power 20 minus 1). This implies, this is the constant, so you can write 2 into f alpha, then summation k is equal to 1 to 10 fk. This is equals to 512 by 3 into 2 to the power 20 minus 1. So this implies f alpha 2 into f alpha into bracket k equal to 1. This is our f1 plus if k is equal to 2, f2, this is our f2, f10 is equal to 512 by 3 into 2 to the power 20 minus 1. This will imply f alpha into 2 plus This is our 2 to the power 3 plus 2 to the power 5 to the power 3 plus 2 to the power 5 f of 10, that is 2 to the power 19. F alpha into 2 plus 2 cube plus 2 to the power 5 up to 2 to the power 19. This is equal to, this is 256 by 3, 256 by 3 into 2 to the power 20 minus 1. This is a GP series whose sum will be a into r to the power n minus 1 by r minus 1. So this is our f of alpha into a into r to the power n. A means 2, r common ratio is 2 to the power 2, so whole to the power n, that means whole to the power 10, 2 to the power 20 minus 1, the common ratio is 2 squared, so 4 minus 1, this is equal to 256 by 3 into 2 to the power 20 minus 1. So this will imply f alpha is equal to 128. This will imply f alpha equal to 128. What is our f alpha? Fx is our 2 to the power twice x minus 1. So 2 to the power 2 alpha minus 1 equals to 128 means 2 to the power 7. 128, that is our 2 to the power 7. So alpha is equal to, so this implies that alpha is equal to 4. This implies alpha equals to 4. So the correct option is C. So the correct option answer is C. You were given f of x plus y is equal to 2 fx into fy. From this we have calculated the value of f2 and you are given f1, f2 and f3. So in general we can write fx is equal to 2 to the power twice x minus 1. Now we start from the given condition sigma k equals to 1 to n f of alpha plus k equal to 512 by 3 to the power 20 minus 1. Break it up. F of x plus y is equal to 2 into fx into fy. So we can write 2 into f alpha into fk. In the second step, as it is constant, we have taken outside the summation notation. This sigma k equal to 1 to 10 fk equals to this thing. So now break it up. This is the GP series whose sum is a into r to the power n minus 1 by r minus 1. First term is 2 and r is 2 squared. So a into r to the power n means 2 squared whole to the power 10 to the power 20 minus 1 by 4 minus 1. This is equal to this thing. From this you can write f alpha equal to 128. What is our f alpha? We are given fx is equal to 2 to the power twice x minus 1. F alpha will be equal to 2 to the power twice alpha minus 1 equals to 2 to the power 7. This implies 2 alpha minus 1 equal to 7. So alpha equals to 4. So the correct option is C. About this chapter's relation functions we'll discuss in the next video in details. You will study yourself and then you will see the other problems.